রম্বিক অ্যান্টিনার সেকেন্ড পার্ট লেকচারে তোমাদেরকে স্বাগত জানাচ্ছি। আশা করি তোমরা ঈদের পরে সবাই ঈদ ভালোভাবে করলে এবং ঈদের পরে সবাই ভালো আছো। তো গত লেকচারে আমি বলেছিলাম যে হাউ টু ডিজাইন রম্বিক অ্যান্টিনা and what is rhombic antenna and how can we design the rhombic antenna, those formula. সেই সাথে সাথে we have to know about the salient features of the rhombic antenna. The rhombic antenna is a very long wire antenna and consists of four non-resonant wires, and it provides a greater directivity than the V antenna. Its bandwidth is high. It is an HF high frequency non-resonant antenna, and it is very useful for point-to-point communication. It is a traveling wave antenna and there are no reflectors. It also finds wide application while the angle of elevation of the main lobe is less than 30 degree. At an elevation angle above 30 degree, the gain is very low for practical application, and the length of equal radius varies from 2 to 8 lambda. The tilt angle varies from 40 to 75 degree. So these things you have to remember of the rhombic antenna. Some other features are that phi is determined from the leg length and the terminating resistance is about 800 ohm. The input impedance lies between 650 to 700 ohm. The directivity varies between 20 to 90. So directivity is not so high. The power gain lies between the 15 and 60 after taking power loss in terminating resistance into account. It is a very useful antenna for transmission and reception in HF band. It is easy and cheap to erect. Now we'll talk about the radiation pattern of this antenna. So this is the feed point and this is the terminating resistor. So connecting this length or axis is called the propagation axis, and it is like a two V-type antenna is connected with each other. So if you consider only one V-type antenna, then you have a radiation pattern like this. If you do not understand the V-type antenna radiation pattern, think about a thin wire antenna and think about the radiation pattern. And if we sum or resultant of the four radiation pattern, we can get this radiation pattern, and this is the radiation pattern of the rhombic antenna. So now if we give a problem, design a rhombic antenna to operate at a frequency of 30 megahertz with the angle of elevation of 30 degree with respect to the ground, then we have to calculate the rhombic height. And in order to calculate the rhombic height, we need to know the lambda, that is the frequency, that is the transmitting wavelength. And wavelength can be calculated from this formula, this well-known formula, and from this we use the previous formula and we can get the rhombic height. Thus we can calculate the rhombic height and rhombic height. So what are the advantages of rhombic antenna? There are several advantages. An end-to-end receiving array of number of rhombics can be designed to form a multiple unity stable antenna system with constant result of ultimate for long distance wave. The great advantage is that input impedance and radiation pattern do not change rapidly over a considerable frequency range. It is a highly directional broadband antenna with the greatest radiated or received along the main axis of the longer diagonal. It is very efficient and widely employed antenna. It is simple and cheap to erect, and input impedance is twice so that obtainable from a single side radiator. And short-wave antennas of this kind require only low height. Rhombic antenna is untuned and is useful wideband antenna suitable for rapid switching from one working frequency to another frequency. So there are several advantages of rhombic antenna. In spite of this advantage, there are some disadvantages, and this advantage is very important. That is that it requires a larger space for its installation. Its efficiency is less, for some power is lost in the termination because it has, if you terminate it with the resistor will give the loss. But if you terminate with open-ended, all this also gives the loss. So there is always loss in the rhombic antenna. And besides the major lobes, a single rhombic antenna produces a fairly large number of minor lobes, and this is also the disadvantage of this antenna. But however, the efficiency of there are various applications of the antenna. It is used for radio communication, shortwave radio broadcasting, long distance communication, point to point communication, high frequency transmission and reception. In spite of the some disadvantage, and due to the large applications, the efficiency of the rhombic antenna can be increased by using the arrays of the rhombic antenna. That means arrays of rhombic antenna connected in series with the antenna. So when you connect it in series, that means the radiation pattern will change and the efficiency also increased 90% or more. So these are the important things about the rhombic antenna. So today is the end of the lectures by saying the Swami Vivekananda's important quotes. Learn everything that is good from others, but bring it in and in your own way, absorb it and do not become others. So thank you very much.